Hi everyone, welcome to the eView demonstration of how to perform Granger causality. So first of all, I'll start with a simple case of Granger causality testing, which is basically similar to the pairwise correlation, which we know from statistics, econometrics 2, econometrics 3, and so on. So in this case, I'm going to use three variables. I'm going to look at the relationship or the impact of bank size, which is measured by total asset, as well as bank risk, which is measured by non-performing loans, or the impact of those two variables on bank profitability, which is measured by return on equity. Okay, so the first step in conducting any Granger causality is always by testing the variables, whether they are integrated of order zero, because the simple Granger causality requires that the variables should be integrated of order zero. If they're integrated of order one or two, then you have to perform a different type of Granger causality. So in this case, I have already tested the variables and they are indeed integrated of order zero. So we start by highlighting the dependent variable. I think by now you guys know that we now always start highlighting the dependent variable with the rest of the variable. Now with the simple Granger causality, once you highlight the variable, you right click and now you open them as a group. So once you open them as a group, a spreadsheet will appear. So while you're on that spreadsheet, which shows you the variables, in the order that you have highlighted them from the dependent variable with the rest of the independent variables. Then you click on view. If you click on view, within the options under view, you have to find Granger causality, which is the second last item. If you click on that, a small box will appear asking you for lag specification. And as I indicated earlier, we don't have to change anything because we might overestimate or underestimate the lag length. So therefore, we leave it to the default lags. So we simply just click on OK, and then we get our final results. So on our final results, we have the null hypothesis here, and we have the probability here. And remember, I said in order for us to make a decision whether or not there is causality, we look at the probability values. So if we look at the first option, and remember now our interest is we want to see whether bank risks and bank size does Granger cause bank profitability or vice versa. So those are our variables of interest. So if we look at the probability in both cases, we actually see that all these probability are actually greater than 0.05, and so therefore it basically then tells us that because of that we cannot reject the null hypothesis of no causality, and so therefore in this instance it basically tells us there's no causality between bank risks and bank profitability, as well as bank size with bank profitability and vice versa. Now, if we come to the last part, in the last part we see it only talks about the causality between the independent variables themselves, which are not the variables of interest. But in any case, just for completeness sake, if we look at the probability value, the last one, we can actually see that there is causality running from bank risk to uh, bank size. And because here we have 0.000, we have 7 zeros before 0.9, and so therefore that is less than 0.05, and so there is causality running from bank risk to bank size. Of course, we know that there is a relationship between total assets and loans, because we know that if we have a situation whereby we have a lot of non-performing loans, and it's basically telling us that there is more default by clients, and so therefore the size of total assets will definitely decline. And if there is more or if there is less default or less non-performing loans, then the risk is low, and so therefore you have more total assets. So therefore this variable can help to predict that, or this variable can help to predict that. So now in this case, since we only have causality running from bank risk to bank size, then we can only talk of unidirectional causal relationship, because there is no feedback coming from bank size to bank risk. Okay, all right. So that's how we conduct Granger causality within, the simple one. So now I'm moving on to the Granger causality within the VAR framework. I'm going to use the work file that we have used before under VAR, where we were looking at the relationship between inflation and interest rate. We were looking at how interest rates affect inflation. So we know that these variables, we have tested them before, we know that they're integrated of order one, and but there was no co-integration, and that's why I'm using this work file for VAR to demonstrate gradual causality under um, the VAR framework. So once again, for you to conduct Granger causality within the VAR framework, you have to go through all the steps: testing for unit root, testing for lag length structure, testing for VAR stability condition, testing for all those other diagnostic tests, and then testing for co-integration. And once you do that and you come to the conclusion where you have to estimate your final VAR, of course, in our instance, I think we know that our VAR model was within, our lag length was between 0 and 2. And I said, for as long as the lag length is between that range, you can use the default one. And so we simply just had, so we just simply had to go ahead and estimate the VAR. So now when you are on that output, all you have to do is click on view, and then you have to choose lag structure. Then under lag structure, you have to choose Granger causality, block exogeneity, and then you have the output. Now remember, during the lecture, in the video lecture, I showed you two equations: x as a function of the other variables and y as a function of the other variable, or vice versa, or y as a function if we take y first and then x second. So in this case, if we take CPI to be y, so we are going to say y is a function of the past value of itself and the past values of interest rate. While here in the second case, we have x, which is interest rate, as a function of its past value and the past value of inflation. Now, if we look at the probability values, so we can basically see that here this 0.00 is less than 0.05, and so therefore in this case we can reject the null hypothesis of no causality. So meaning that yes, indeed, the past values of interest rates are different from 0, and hence there is causality running from interest rate to inflation. But now if we go down to the second equation, we can actually see that the probability value is greater than 0.05, and so therefore here in this instance we couldn't reject the null hypothesis of no causality. So meaning in this case the coefficient of the past values of inflation in this case were actually equals to 0, and that's why there's no causality running from inflation to interest rate. And that is basically how we conduct a gradual causality under the VAR framework. Now, one thing that you should take note of is that we don't have, if the objective is only to check for causality, we don't have to go ahead and do impulse response and virus decomposition again, because that's not our objective. Our objective was only to determine causality, and so therefore this is what the results tells us. And that is how you conduct causality within the VAR framework. Now, if we have to do it within the VECM framework, again, I'm using the work file that we have used under VECM, where we looked at the impact of interest rate on uh, credit. So again, after you have done all those tests, from unit root test, lag structure or lag length rather, VAR stability condition, and other diagnostic tests, then the co-integration, when of course in our case the work file that we have used under VECM there is co-integration, and so we had to estimate the VECM. So we start highlighting, in this case, of course, let's just highlight our variables so that we can estimate that final vacuum that we estimated before. And again, I also recall that our lag length was between 0 and 2. That's why we didn't change. We left it to the default. So when you are on that final vacuum, vacuum. So you just like under var, you just click on view, uh, choose lag structure, choose gradual causality, block exogeneity, and then you get the output. You see the outputs are just similar. The one similar to the one which is under the VAR framework. So again, you look at the probability values, and in this instance, actually, there is no causality running from either, no causality at all. So meaning the two variables are independent, and so therefore there's no causality running from either of the two. So that is basically how you conduct Granger causality within the VECM framework. So to sum it up, so I demonstrated to you the three cases of the simple Granger, then the Granger within the VAR framework, and the Granger within the Vecam framework. You can actually see that with the simple Granger, you don't even need to estimate anything. All you do is the moment you find out that the variables are integrated of order 0, you just open them as a group and then you do the necessary test. It's only under the var and the vacum that you have to go through that process again of estimating. I mean, first of all, making sure that the conditions are met also from the unit root test and all those other necessary tests. Once you do them, and then obviously you can then just continue with the rest uh, and then you do the necessary Granger causality test that you have to do and interpret the results as such. That is really how you do the Granger causality. So sometimes you will find studies will combine the two. First, they will uh, be interested in doing the VAR or VECM, and then within that they can still do the Granger causality. Actually, that's why that's why in general also sometimes the VAR models are considered as means or ways of conducting Granger causality because um, it's system of equations and they sort of give you the feedbacks of whether the past values affect the current values. And you know that VARs are autoregressive models and they are usually or they actually involve um, they involve they do involve past values and so forth. So that is really how you do it.